Hi everyone, Bradley Bush with another algebra video. Today we're talking about the topic of solving exponential and logarithmic equations, and specifically we want to focus on how to use factoring to solve exponential equations that may be written in a quadratic form. So there's the overview, and let's talk about our to-do list. So we'll talk about what the factor trick is, and then we'll give an example of it. So let's start. So the factor trick, sometimes exponential equations are written in quadratic form, and if it's hard to remember what quadratic form is, it's this right here in yellow, the a times x squared plus b times x plus c. So the a, b, and the c will just be numbers, and instead of having x there, you may have an exponential. So you might have an exponential raised to the second power and an exponential multiplied by b. So we're looking for things that kind of look like parabolas. We can rework them to make them look kind of like parabola form or quadratic form. So let's take a look at a problem. So here's our problem. We want to solve e to the 2x minus e to the x, 8 times e to the x plus 7 equals 0. We want to solve for x. So this, when we look at it originally, initially we don't really think, hey, this looks like a quadratic. But if we look at this, if we say, hey, check this out. E to the 2x is really the same thing as e to the x times 2, which is really the same thing as e to the x squared, right? So some quantity squared. If we say, well, let's let e to the x, we're just going to change it. We're going to say everywhere there's an e to the x, we're going to write u. Then our above expression right here becomes u squared. And u squared, that looks like something that is in a quadratic equation. Some quantity squared, just like x squared, u squared. That's just a parabola. So this is the trick. This is actually the key to this whole problem process. So let's go back to our problem. What if we do say, let e to the x equal u? So if we rewrite our original problem to be e to the x squared minus 8 e to the x plus 7 equals 0, then that means the e to the x and the e to the x squared is now u, and the negative 8 times e to the x is now negative 8 times u. So if we make that substitution, now we have u squared minus 8u plus 7 equals 0, which is perfect. That looks just like a quadratic equation, just like a parabola. If we graphed it, it would be a parabola opening up. So now we solve this equation, and we look at it and we think, well, we can probably factor. So let's factor. When we factor this, we will end up getting u minus 7 and u minus 1. Now we see we can use the zero product property, where we have something times something else, and those two things are equal to 0, because we know that if we have two things multiplied together and their product is 0, meaning the result is 0, then either the first thing is 0, or the second thing is 0, or they both are 0, right? Because 0 times 5 equals 0, 5 times 0 equals 0, and 0 times 0 equals 0. But if we have 1 times 5, meaning neither of them are 0, then we can't get a result that's 0. So we can come back here and say, let's take this first term and set equal to 0. See what we get. So u minus 7 equals 0. We take this negative 7 to the other side, and we get u equals 7. When I say take the 7 to the other side, that just means add 7 here to the left, add 7 to the right, and we get u equals 7. Let's try the other side. And we have u minus 1 equals 0. If we add 1 to both sides, we end up getting u equals positive 1. So we've solved these equations for u, but our original equation was not in u. Our original equation had x's in it. So we've got to go back and substitute back in the u equals x squared. So let's do that right now. Since u equals e to the x, then that means that the u equals 7 and u equals 1 are now going to change. We're going to rewrite them as we will have, instead of u equals 7, we'll have u equals e to the x equals 7. So really what we care about is the equation e to the x equals 7. And now we have to solve this problem. How do we solve this problem? Well, if we use logs, we can get that x out of the exponent. Remember? The x comes down when we take the log of both sides. But this is base e, so why don't we just use the natural log, and then we can just cancel out the e. So we'll have natural log equals natural log. So we're taking the natural log of both sides. On the left we have e to the x. On the right we have 7. The e and the ln cancel, and we have x equals the natural log of 7. Awesome, we're done with that one. Let's try the other side now. We've got to go back and finish the u equals 1 equation, because u also equals e to the x, which equals 1. So we substituted back in e to the x for u. So now we have to solve e to the x equals 1, just like we did on the left-hand side. So again, if we take the natural log of both sides of the equation, then we have ln of e to the x on the left and the ln of 1 on the right. And the e to the x and the ln cancel, and we're left with x equals the ln of 1. And the ln of 1 is actually 0. So we're done. If If you have any questions, let me know. Thanks for watching.